Okay, good morning. This is Professor David J. Delosreyes. Okay, my topic for this session will be a long video format discussion on this will be lesson number 2 on alternating current machines. This is a long video format discussion. Okay, let's proceed. I am now on lesson number 2 on my alternating current machines long video format. Okay. So the topic for this morning will be, it's September 6 already. Alternating current machines, lesson number 2. And the title of the topic is transformer construction and the way how to call off transformers. Okay, that will be the next one. A subtopic for the transformer construction. Okay, let's proceed. There are only two types of transformer construction. For the meantime, we will just consider single-phase transformer. Okay, it's not three-phase. We are not yet on the three-phase, single-phase transformer. The two types of construction of transformer is the so-called core type and the shell type. The diagram for a core type, okay, so our lesson for tonight will just be something like storytelling, right? But at least we are educating people for those who doesn't know yet about transformer, about the construction of transformer, how transformer are constructed, and what's the inside of the transformer. Okay. The number one construction type is the so-called core type. The core type is something like this. We got a steel plate lamination, this rectangular area. This is the primary winding. This is the secondary winding. Why are the windings in red? It's just like a winding that was wound around the core, right? Then we cut it. We cut the cross section. So actually, these small rectangular things here are actually the cross section of the windings. We got a winding that is wound, right? We cut it like that. So we are facing the cross section. So this is actually the cross section of the winding. Okay, that's how deep the winding was wound, right? So we cut it like that. So this small rectangles over here represents one conductor. Okay, so it's a wound of the, we call it a primary winding, secondary winding. So for a core type, this is the lamination which is made of steel plates, right? We are just on the front view. So if you see a steel plate, they are what they call this. They are assembled like that, okay, in sequence. So it could be more than 50, maybe 20. It depends. But they are made of the so-called steel plates, and we call it lamination. Okay. For the core type, we call this portion here the secondary leg, and for this portion here, we call it the first leg. This one, first leg, second leg, secondary windings, primary windings. This is the common core lamination, the steel plates in which the flux will run, right? This is where the flux will move, right? Magnetic field, flux. Okay, so for a core type, that's the construction. Okay, that is only single phase. We are not considering for the meantime three phase, single phase, right? Meaning there are two lines here and there are two lines here. That is considered single phase, right? For the shell type, it's a more complicated thing. I think the core type. I think what's the how the winding of an oven is wound. I think it is something like the core type, or it could be the shell type maybe. The magnetron of an electric oven. Okay, the construction is, it is something like this. But those are not power transformers. It's still considered power transformer, that, but they are exclusively for some small equipment. What I'm talking about here is actually the transformers that we are using to power up our houses and businesses. Okay, so these are distribution and power transformers. Because the next time around, I will be discussing the difference between a distribution and power type transformer. Okay, and that will be the next topic maybe. For tonight, we are just only discussing how transformers are constructed. So I will repeat it. The number one type of construction is the core type. Okay, this is the primary side, this is the secondary side, and this is termed to as the so-called core type. The second type of construction is the so-called shell type. Okay, the lamination is this. It got a center leg. Okay, so the way how the shell type construction is made is that, considering the first leg, okay, the first leg, the first winding that is placed on the center leg is actually the primary. So actually the blue cross sections represents the primary windings. Okay, the blue cross sections, that is the inner winding. Okay, it is the first one to be wound around the center leg. Okay, it depends on how many turns. It depends on how it was designed. Okay, so the inner winding is actually represents the primary winding. Then next after that, okay, it will be covered by an insulating material. Okay, then next to it, it will be the secondary winding that will be wound. Okay, so primary winding, it will be covered with an insulation. Okay, then after that, the next winding to be wound will be the secondary. So actually, the red cross section represents the secondary winding. Okay, it is the outer. This is the inner. Inner meaning it's the first one that is being placed, wound on the center leg, the primary winding. We place an insulation in between. Okay, then we wound the secondary winding. So the red cross section here represents the secondary winding, the blue represents the primary winding, and they are connected on the center leg. Okay, and this is the common leg. Oh, this is termed to as the lamination or the iron core, this one, where the flux will circulate, right? Okay, so the use of the lamination is actually the pathway for the magnetic flux, okay, to circulate, okay, even on the first one. It's the pathway of the magnetic flux or the magnetic field. That's for the lamination. So for the core type, this is the figure. For the shell type, this is the figure. So you can see the difference. Okay? Core type, shell type. Primary winding is the inner one, the one in blue, and the secondary winding is the one with the cross-section red. For the core type, there's no problem because the location of the primary and secondary windings are actually away from each other, right? Okay, this is the primary winding, the red cross section. The red cross section on this section here, on the second leg, is actually the secondary winding. So this is the core type construction, and this is the shell type construction. Okay, this is just storytelling, but we are educating people now. Okay, next one. The ways of calling transformer, because transformer actually carry so much current, okay, and the voltages applied to them are actually very high, okay. So actually there should be the so-called heat dissipation inside, and to call off transformer for a longer life, okay, there are ways on how to what they call this call off transformer. There are 5 over here. By mutual radiation and convection. Okay. Number 2, Transformer windings could be oil immersed, self-cooled. Transformer windings inside the cylinder can could also be oil immersed, water cooled. Number 4, you apply an air blast, or you apply something like an electric fan or a blow of air for the windings to cool off. Okay, so air blast. And number 5, oil immersed with external fans. Okay, I want to draw all this one, but it takes a lot of time to draw this one to show you, so I will just take up my nose just to show you. Okay, this is the way how to cool off transformers. Number 1 is actually to increase the surface area. You try to corrugate the, what do you call this, it's just like the, what do you call this, the cover of a beer, right, in bottle. Okay, you try to corrugate that cylinder thing. You try to corrugate this one. Okay, it will not be a perfect circle, but you try to corrugate to increase the surface area. Okay, to increase the surface area. So if the surface area increases, okay, the surface which will dissipate heat will be more. Okay, so that is actually by mutual radiation and convection. Because if we try to define convection, it is heat transfer to the surface naturally. Okay, so if the transformer is not oil immersed, it will just be simply a dry thing inside. Okay, for it to be cooled off, at least the surrounding surface area should be more, so it could dissipate more heat. Oh, that's number 1. Oil immersed is something like this. Oil immersed. I don't have it. Oil immersed, this is just a transformer, front view. The windings are inside. It's filled with oil. It's filled with oil. Okay? So they are oil immersed. The problem is how to dissipate the heat to bring it out. So one method is actually we have electric fans outside the transformer. Specialized electric fans to cool off. Okay? Specialized. We got oil inside. To bring it out, you still have some electric fans outside. Okay? The other one is actually, we got a hole here and we put a blast of air, okay, to cool off the transformer. This method is actually being done in the so-called large substations, okay. What's next? Oil immersed self-cooled. Oil immersed, we put some oil over there, okay, then it will just dissipate naturally to the surrounding around the corrugated surface. That's oil immersed self-cooled. Number 3 is oil immersed water cooled. Water cooled something like where's water cooled over here? It is this. Okay. It's just like what they call this, a coil for a refrigerator or an aircon maybe, in which this coil passes through the inside. Okay, so the heat inside will be absorbed by the coil, but since there is running water about it, it seems it is just like the water cooling of a car, right? The water is circulating, it passes through the radiator, then it will be blown by the air, so the heat that comes out from the transformer is blown out. Same true with transformer, it's like that. Okay, so we got a cooling tubes inside the transformer that passes a cold water, in which this running water is going in and out. As it goes out, it brings out the heat from the transformer. Okay, so that's one way of cooling off transformer. What's next? Oil immersed water cooled air blast. I think we have this air blast over here. This one. we got an outlet over here, there is an air blast on the other side, so a cold air will be blown to the transformer so we could dissipate the heat that's generated inside. There are lots of heat inside because thousands of currents are actually passing through the windings. Okay, due to our consumption from our houses. Oil immersed with external fans. I think it's this. Okay. To the side of the transformer, we got a tube that comes from inside, and to cool off that tube, we got electric fans. Okay. Using cooling pins and cooling tubes. It is something like this. If you have seen a transformer casing, it is actually cylindrical. If you have seen transformers that is hanging on the pole, sometimes you got see what they call this, something like a tubing around the transformer like this that goes around. It's so many, maybe more than 12. Okay, it's constructed, it's like that. So that's one way of increasing the surface area in which the heat inside will be dissipated. Because by just corrugating the surface area, it's not enough. So designers added some cooling pins outside. Okay, so there are more cooling pins outside. Okay, of course the surface area is small, so we could cool off the transformer faster. Okay, that's cooling tubes. The cooling pins, it's the same as the cooling tubes. It's just that I think it's a rectangular thing. And instead of a round thing for a cooling pin, it should be something like this, rectangular. It goes around the transformer. It was welded on the casing of the transformer. So it adds more surface area to dissipate the heat. That's cooling pins. The first one is the cooling tube, the round ones. Okay? So it is not just by corrugating will increase the surface area. We add more cooling tubes and cooling pins, the rectangular one. Okay, it was welded on the casing of the transformer. Okay, that's it, guys. The way on how to construct a transformer, I will repeat it for the last time before we go for this morning. The core type and the shell type. The core type, this is the primary winding, this is the secondary winding. The primary is separate from the secondary, they are far away from each other. For the shell type, they are connected on a common line at the center. The first winding to be wound is actually the primary. It will be covered by an insulation. Then after that, the secondary windings will be wound, and that comprises the windings of the primary and the secondary. So the inner one is the primary. The outer one, this is a cross section, okay? This is secondary winding. This is the lamination. We call this the common line. This is the lamination also in which the magnetic flux is circulated. The way of cooling transformer, I will repeat it for the last time, by my motor radiation and convection. It's the normal heat transfer to the surface. Okay? Number 2, oil immersed self-cooled. Oil immersed self-cooled, we just place oil inside, then it will cool by itself. The heat dissipated will just go to the surroundings. That's self-cooled. Oil immersed water cooled, there is still an oil inside, but we put some what they call this tubing inside. When heat water is circulating from inside and outside, okay, it will go in and out, so it will dissipate the heat that's being taken from the inside. That's water cooled. Okay, so it seems this is just like similar to the construction of a car, in which we dissipate the heat generated by the engine. Okay, we put a coolant, that coolant goes around the engine, and that coolant goes to the radiator. The radiator will be blown by the electric fan of the car. So we will dissipate the heat outside. Next one, we will put an air blast. Air blast, something like we put a hole over here, then we put a hole over here, but we apply the air. So air is actually blown inside, it will come out on the other side. So actually we are calling also the transformer, that is air blast. Oil immersed with external pins. I think I have shown you this one. Oil immersed with external pins. Oh, this one. The other type of pin is something like this. Okay. The way it is constructed, okay, these are pins. So that's one way also of increasing the surface area of the dissipating area to dissipate heat. Oh, that's it. Using cooling pins and cooling tubes. Okay, that's it, guys. At least we now know how transformers are constructed. We now know how transformers are being called up. Okay, so the next time around, we will be discussing what's next. The ratings of the so-called distribution in power type transformer. We will classify a transformer if it is distribution or power type. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes.